Okay. Hi, everybody, and welcome to the first live event that we organize here at Telescope Live. Today, we're here to image the great conjunction of Jupiter and Saturn from Spain. So we're going to connect to one of our telescopes in Spain, in Andalusia, right now, to observe the conjunction of Jupiter and Saturn. We're going to observe these two planets coming very, very close together, as never happened in the last few centuries. So let me give you a quick idea of the agenda for today. We're going to have a short introduction about astrophotography, remote imaging, and Telescope Live. And we are going to have a first announcement to our Telescope Live users. Today, we'd like to share with you a couple of announcements, which are specifically for our users and maybe for our future users as well. And then, of course, we're going to talk about the Great Conjunction, the reason why we're all here. We're going to talk about what it is, why it's a special event, why it's rare, and then, of course, we're going to observe it from Spain. We're going to join Colin from Spain. We're going to connect to our 70-centimeter telescope and observe the Great Conjunction. We'll have some Q&A time. We have around 140, 150 users connected through Zoom in our webinar. These are part of the they are part of the Telescope Live community, and through Zoom they will be able to ask questions, and we'll try to answer them as we go along. Then we have a second announcement, a special gift for Telescope Live users, current users and future users as well. And then stay until the end of this presentation, of this live event, because we have some world-renowned astrophotographers who are going to share with us their view on astrophotography and their experience with astrophotography, Nick Simonek, Adam Block, and Peter Jenkins. All right, so let's start. Well, first of all, I'm Marco Racchetto. I didn't introduce myself. I'm one of the founders of Telescope Live, and we like to define Telescope Live as the new home for astrophotography. We offer a whole new way to observe the night sky. So let me start with what is astrophotography. I'm sure that most of you already know what astrophotography is, but for the sake of completeness, let me say that astrophotography, as the name suggests, is the art of taking pictures of celestial objects. We have a camera mounted on a telescope to record the light coming through as seen by telescopes. And it's not only that. Once you take these images, you post-process them, and Nick, Adam, and Peter, we talk about this at the end of our event to create these stunning images. So the images you see here, that you see in our Instagram feed, if you follow us, or that you can see online, are all obtained with our telescopes, doing post-processing. And we're going to talk more about this in a moment. Okay, let me give you a very quick overview of what are the enemies of astrophotographers. And I guess one of the reasons why you're here with us today is that you maybe weren't able to see the Great Conjunction because of bad weather. And in fact, we've all experienced the frustration that comes along with not being able to go outside. Well, even if you're not an astrophotographer, when there's bad weather. And there is a related issue that even if it's clear, you go outside, you look at the sky, and you can't see much because there's light pollution. And I usually live in London, and believe me, 80% of the time I experience the first issue. And even when it's clear, I go outside at night and you can't see many stars. There's then, of course, another issue which is related to your location. I'm pretty sure you know that the skies are different in the southern and northern hemisphere. So what you can see in the sky depends on when you are on the Earth. And if you are in the northern hemisphere, you can't simply access southern hemisphere targets. And lastly, even even if all the other elements are good weather, good dark skies, the issue is the lack of time. Most of us don't have the time to observe the sky, to take astrophotography pictures, because it does require a lot of time and effort. Now, Telescope Live, as a remote imaging platform, is the solution to all these problems. So as I said, Telescope Live is a remote imaging service that can be accessed through a website, through a web application. You create an account and you can use professional telescopes located in different sites around the world from the comfort of your home. So you can forget about bad weather conditions because all these observatories are located under the best skies. They are under the dark skies as well, so light pollution will be just a distant memory. All the observatories are actually located in the equivalent of the paradise for every astrophotographer. They are in locations such as deserts and mountains, high up in the mountains. And lastly, well, you can observe from both hemispheres without leaving the comfort of your home, because all these telescopes are located both in the northern and southern hemispheres. And finally, time won't be a problem anymore. We have different observing modalities that will allow you to get stunning astrophotography pictures in a matter of hours or, well, a few days, depending on the weather, without really doing lots of the hard, tedious work that is required to set up your gear and so on. So let's have a quick look at the Telescope Live network. We are going to use one of our telescopes to observe this live event. Let me first show you what we have in Chile. This is the event we are in right now. We're going to connect to Spain. It needs to be just after sunset, and it's just after sunset right now in Spain. But our second event that we're going to host in a few hours is going to be from Chile. And this is our observatory in Chile, is El Sos Observatory. We have many telescopes there, and we're going to use the one in the middle to do that. Then we have our Spanish observatory. It's called ICU Astronomy. That's where we're connecting to. We're going to use a 70-centimeter reflector, the one you see on the bottom here. And in the chat today, in the event today, we have Colin directly from Spain. So I'll mute myself, I'll stop the screen share, and Colin will be able to show you our observatory. So give me a moment. Colin, you have to unmute yourself.
That it? I'm not muted, I don't think.
You're going the wrong way. You're facing the other way.
Colin,
Hello?
it's good. Yeah, you can go ahead. We can hear you.
Okay. Okay, so we're here at ICU Astronomy, 1,280 meters, and as you can see, the sun is just going below the horizon. So we're going to get dark pretty quickly. So I'll give you a quick tour of where we are and what we do. We've got we've got 5 roll-off observatories, and we'll have a quick wander in one. We house everything from 4-inch refractors up to 17-inch RC there, plane wave, varying scopes everywhere. And I've just got, hang on, let me just get into the light a bit more. And we're high in the mountains. And if you can see in the distance of the image there, there's a peak. That is actually where Calar Alto is, which is one of the largest observatories in the Northern Hemisphere. It's about 30 kilometers away as the crow flies. And now if we wander into OBS 4, which houses our nice little 700 millimeter. There we go. You'll go.
Yeah.
Got it?
Yep.
So just to give you some sort of perspective on size, there it is, 700. So it's a focal length of about 4.2 meters at f6. It weighs about 2.5 tons. And this building was specially made just for this scope. Yeah, very nice piece of kit. And we're quite proud to have this thing here. Yeah, as you can see, let me get some sort of. So on here we've got a finger leg, all finger leg equipment, camera, filter wheel, and very nice indeed. And we're going to run out of light pretty quickly. And hopefully, you can see that we've got a bit of wispy cloud above us. We're hoping that's going to clear away enough so you can get this event on the scope. Where's Marco? Is he back in there? Oh.
Thank you very much, Colin. I guess. Thank you, Colin. So stay there while we pass the word. Well, actually, I want to finish my presentation. So let me share the screen again. Here we are. So this is, as we said, our observatory in Spain, and we're going to connect to the computer that controls the telescope in a moment. And here is when we were getting ready. We have another observatory in Australia. So that's again the southern hemisphere. And you can basically access all these telescopes and obtain great pictures of the night sky using 3 observing modalities that we offer in our platform. One-click observations. If you're a novice or just getting started, you want quick results, you don't have much time, you can use one-click observations to get quick color images of the night sky. And we also provide the raw images for each one-click observation that you can post-process following some of the tutorials that we produce. We then have pro data sets. These are complete sets of raw images that you can post-process straight away. You can download them and post-process them straight away. And then we have advanced requests, which allow you to tweak every aspect of your observations. And that's not all, because we also have plenty of learning resources. In fact, with us, you can actually learn from the best. And we have some world-renowned astrophotographers with us. Some of them are with us today. So stay until the end of the meeting, at the end of the live event. Peter and Nick, and hopefully Adam as well, will give us a short presentation. And you'll be able to find lots of video tutorials from Adam, Peter, and Nick on how to post-process astrophotography pictures. So before I pass the word to Alex, who's going to talk about the Great Conjunction, I'd like to have and broadcast an announcement mostly for our existing Telescope Live users, but really for everybody else. So today we're launching our community, the Telescope Live community. We thought that besides our own platform, we also needed a sort of virtual living room where our users will be able to gather in a friendlier way and start conversations together in a more immediate and direct manner. So join the group now. You can search Telescope Live community on Facebook. You can join the group, start the conversation. It doesn't need to be about the Telescope Live platform. You really want to encourage conversation about every topic connected to astrophotography, techniques, news, and much more. All right, so a little bit, well, our Telescope Live users are already using our platform, but for who's not part of Telescope Live yet, you can go to telescope.live, you can Google it, and you have a 1-month free trial. You can access all the features we've been talking about earlier for free for a month. All right, so I'll pass the floor to Alex, who's going to talk about the Great Conjunction, what the event is, while I go to the telescope and I do some setup before we can observe the event. So Alex, I'll stop the sharing here, and you can share your screen.
Okay, hi everyone.
Alex?
My name's Alex. I'm a sort of co-founder of Telescope Live, and I already spoke to some of the participants in the Zoom webinar group that we have going at the moment. But for a lot of the people that are also watching from the YouTube stream, if you've ever sent a message to Telescope Live, chances are I may have spoken to you at some point or another, or you know, perhaps written some rather confusing emails that you may not have understood, and probably neither did either. So I'm going to share my screen now, put up the slides. So what is the Great Conjunction? Really, this is in terms of the Saturn-Jupiter conjunction that we're watching this evening, this is a really once in multi-generation event. The last time that this happened was about 400 years ago, and the next occurrence isn't for another 400. What's happening in the night sky is the planets are coming together at a point where you can see them through any telescope, and any method of astrophotography will be able to see these planets aligned. So here we have a nice diagram. So this shows you exactly what's going on here. So you have Jupiter and Saturn in a single line of sight from Earth. And this isn't to say, you know, the planets are going to collide in any way. They still sit on their same rotation around the sun. However, you'll be able to see these two planets. And if we move towards this next slide here, you can see here over the last month or so, the planets have been getting closer and closer and closer together. And over the past week or two, and a lot of people that I've spoken to and people that have joined us this evening have already been out and imaged, you know, some great images of these two planets. So, hasn't happened since 1623. I said that earlier. Isn't going to happen again. And we can see here, this is an old article from 1763, diagram showing, you know, the different points of conjunction over the past few hundred years. So it is a rare documented event that, you know, we're not going to see again until the year 2400 and whatever. So it's a, you know, very rare opportunity. It's also worth mentioning that at the moment, it's not just something that you need to do astrophotography to view. Anyone can go out and see this. It's very much like the Neowise event that we had a few months ago. You know, it's visible to the naked eye. So even if you don't own a telescope or, you know, any fancy camera to take an image of it, you can still go out and see it. Granted, the planets are actually so close now that you will only see a single point in the sky. You won't see two individual planets, which is kind of the remarkability of what's going on here. You know, they're so close together that, you know, we can't distinguish between Jupiter and Saturn. So out on this diagram, it shows you here 45 minutes after sunset, you can go out and look southwest and you'll be able to see these planets aligning. And so the actual conjunction between these two is in about an hour's time. It's at 6:22 Greenwich Mean Time or UTC. So in about an hour's time, if it's dark or dusk where you are, you can go out and you'll actually be able to see these two planets coming together. You'll also be able to photograph them with your phone or any telescope and other photography equipment that you may have. So I think now we're going to go towards Marco to show you what's going on the telescope. We're using this telescope to give you a very in-depth look at what is actually going on. So I'll hand over to Marco, who's now going to show you on connect to the telescope and show us what's going on.
Thank you, Alex. So I'm going to connect to the computer that manages our telescope in Spain. Give me a second. I'll share the screen. Desktop 2. Sure. Can you see my screen? Fantastic. All right, so this is the computer. It's a Windows machine that controls the large 70-centimeter telescope that you've seen, that Colin showed us. We have a webcam. We can see that it's quite bright, and this is why this event is so difficult to image, because we're observing it very low in the sky, very close to the horizon. We're at around 17 degrees elevation right now, so it's very low. Lots of atmosphere to go through, and there is also a wall. You probably have seen this before. There's a wall in front of the scope, so we don't really have much time to grasp this event, but this is what we're doing today. And I set this up for you. We use the sky. Many of you might be familiar with this, and you can see that we are already below this orange line, which represents the horizon that we set for our telescope. So you can't usually observe so low. And here we have Jupiter and Saturn. This is a planetarium software. We're pointing at these two planets, and the event is so special because we are seeing these two planets really, really, really close together. And this is what doesn't really happen. So I'm turning over to MaximDL, which is the software we use. And here we are, the two planets in the same field of view with a separation of only 6 arc minutes. And well, you can see Jupiter at the bottom, Saturn at the top. Now you can see that one is overexposed. So the one at the bottom is quite overexposed. The one at the bottom is Jupiter. Jupiter is quite overexposed, where we have quite a good exposure on Saturn. You can see the rings. And now this is because Saturn is not as bright as Jupiter. Jupiter is several times brighter than Saturn. So what you can do here is to adjust the contrast ratio with through a stretch, a linear stretch, and you can try basically to see exactly here we are, to see Jupiter, to better expose on Jupiter. And if you zoom in with your eyes, you can start to see some of the features of Jupiter. You can still see some bands, but as you do that, you start to Saturn starts to disappear. Another thing that we can try is to try to look at Jupiter moons. So Jupiter has 4 moons that are always very, very visible. And here we are. So we can see 2 for sure, and 3. 1, 2, 3. So these are the Jupiter moons. And these move quite fast. I mean, if we reobserve this in a few hours, the moons won't be there. All right. So what we'd like to do now, I'm exposing all the time. So this is live. We're taking images with an exposure time of 0.2 seconds. We have a sub frame out of the big chip, and we leave it there until the sun, until the 2 planets go below our horizon. And in the meantime, we can answer some questions and start some discussion. So I leave it here. Right. So Chantal, I'll pass the floor to you. You can manage some of the questions. I'll just repeat to our Zoom users, and at this point, even on YouTube, there is a bit of delay. So with YouTube, but you can ask your questions on YouTube, do it on the Q&A of Zoom as well, and we'll try to answer them live. So I'll leave the floor to Chantal to manage this. Thank you.
Hello, everyone. I'm Chantal. I'm the Marketing and Communication Manager at Telescope Live. And we already have some interesting questions. I'm looking forward to see some more. So drop your questions. The first one is from Conrad, and he's asking if he will be able to get a video to process of this.
Okay, I can comment on this. You're not going to get a video of this because we are using a CCD camera to observe the event. We have a part of the second announcement. It's exactly about this. As you might know, to do high resolution imaging of planets, you actually need a different setup. You need a CMOS camera with a very narrow field of view, very small pixels. And what you do is to basically take a video of a planet, and you then use a technique called lucky imaging to stack them together and obtain a high resolution image of the planet. However, this is not possible. It's not possible to observe such an event with that setup because the field of view is too narrow. So what we are seeing today is the conjunction of the two planets. So the event is special because we are seeing the two planets in the same field of view. So you're not going to get a video, but you're going to get the experience of observing the two planets getting as close as ever. Chantal, I don't know if you see the YouTube chat here. I'm just going quickly.
Yes. I have
asked, why are you using an H-alpha filter? This is a little bit technical, but I'll go through quickly. The other thing you might see is that this image is in black and white. You might have expected a great color image, but that's not how we observe and we take images with telescopes. So what we do is to observe targets, deep sky objects, we're going to talk about this later, and planets using different filters. And here you can say we have a filter wheel. The images are in black and white, but we put a filter in front of the camera to let light from a given color go through. And then we stack together different filters to create a color image. Now we have luminance red, green, and blue. These are so-called broadband filters, which map the cones in our eyes really to create color images. And then we have special filters. We call them narrowband filters, H-alpha, S2, and O3. These are usually used to image nebulae, the large extended objects like the pillars of creations or the Helix Nebula. And those filters only let specific wavelengths through. So with H-alpha, we're talking about the hydrogen alpha line, and this is light that comes from excited hydrogen. And this is why, you use H-alpha to observe nebulae, because nebulae are usually made of hydrogen, of excited hydrogen. We're using H-alpha today to observe this planet because Jupiter is super bright. It's so bright that even with the shortest exposure time that we can have with the CCD camera, we have a mechanical shutter here, which is 0.2 seconds. It saturates if we use a red, green, or blue filter. So we use H-alpha filter because it's a narrowband filter that lets very little light go through, and therefore we don't saturate. But yes, it's not really the right filter to use to observe, to do planetary imaging.
Next question. Do you plan to have a colored image?
Not of this very event, no, because as you can see, the resolution of the image is not as great as you might have thought, right? When you think about Jupiter, you think about all these rings. When you think about, when you think about Saturn, you think about all these rings. When you think about Jupiter, you think about all these bands, and you don't really see them here. And the reason is that we're not really doing planetary imaging here. We're observing still with a relatively wide field telescope the event. So what we're imaging here is the conjunction. It's not really a high resolution picture of the event. If you wait a few minutes, once we finish our question time, I'll show you what planetary imaging is able to do.
Well, I have a few more. And the first one is from Iqbal from our YouTube chat, and he's asking why is so rare as event.
So why is it so rare? This is, I guess, for Alex.
Yeah, hi there. Thanks for your question. So what we have going on here is our solar system, and this is quite a common misconception, I guess. People don't understand how vast our solar system actually is and how much distance there is between each of the planets. And so what's going on here is the planets go around the sun, continually, and they're on different planes as well. Their planes vary, bit by bit. And so what's happening here is for them to line up where you can see them or see both of them at the same time only happens every few hundred years. And this is a very rare occurrence. I think that's quite a nutshell of of why this is happening. There's not much more to it really than, you know, the chance of these two planets in our night sky to be in the same position at the same time is, you know, a super rare occurrence. And it's something that's, you know, it's to go and observe and to be a part of, which is great.
Thank you, Alex. And next one is, how will this conjunction affect the other planets or other members of solar system?
Who wants to answer here? Let's see if other people want to answer. Nick, Peter. You need to unmute, Nick.
If I understood the question correctly, it won't affect the planets in any way, shape or form. It's just a chance alignment of the planets. In reality, they're separated by millions of miles. So what we're seeing is an incredibly rare event, but in reality, the planets aren't actually that close together physically. So it's just, we're just very lucky to be able to see this happening as it is at the moment. There's no actual, no physical events actually happening.
Thank you, Nick. We have a few more. Do we want to go on, or?
Yeah, I guess we
there
can
are also
try.
some very creative ones, such what's the meaning of life?
Go for that.
Or
go for that.
What's the meaning of life?
And another one. Can you point your telescope towards
can
the
you?
pole? Well, let's try. We have, when we search for objects, actually, I'll demonstrate this. We use a planetarium, such as this one. Let me see if I can show it to you. Right. So to look for Jupiter, I simply searched Jupiter. I centered the planetariums towards Jupiter, and then I clicked slew. So I can try with God, and let's see if we can find God. No. So I'm sorry, God was not found. So maybe next time.
Thank you, Marco, for trying to pointing to God. Another question. Is it possible to have graduated split filters to balance exposure on some telescope CCDs?
This is quite technical. Can you repeat that? Where is it?
Yeah. It's on our chat.
Can you repeat the question? I didn't quite get it. Or you can type it.
Is it possible? Yes, I can type it again. Is it possible to have graduated split filter to balance?
I need to add Adam.
Adam Block is here.
Give me a second. Sorry, I'm the host of this, so I need to approve and disapprove what happens here. So please continue. I'll try to do this.
Yes. So I repeat the question once again. Is it possible to have graduated split filters to balance exposure on some telescopes, CCDs?
No.
Yes.
Thank
okay.
you, no.
Thank you.
Simple answer.
Another interesting one is, how old is this image, as its mass takes time to travel from space to Earth?
I can't tell you exactly, but it depends. I mean, we're talking about tens of minutes. Maybe Alex or some of you knows the right answer, but it's on the order of 15 minutes, maybe.
Yeah, I'd say maybe under 10 probably is, yeah, minimal amount of time.
Another question similar to this. What's the actual distance between Saturn and Jupiter? I mean, I didn't know from the top of my head, but I just checked it, and it's 456 million miles. That's the actual distance of the two planets, and we're seeing them so close together. I mean, this is 6 arc minutes. It's really a short angular distance. So that's why it's a rare event. You know, we're talking about two planets that aligned over a plane that it's half a billion miles long, and you see them almost touching.
Thank you. There are a few regards which kind of telescope would we advise as a good starter? And thank you for asking those questions, but these are definitely questions and topics that we will be talking in our community group. So feel free to ask those kind of questions, and the whole community will answer and start a discussion about which is the best telescope to start with, which is the most advanced one, budgets, and all those stuff. Something for us. What is the largest number of planets in alignment at one time that we will see in our lifetime?
I think that's it, but Alex, tell me if we're wrong.
I think this is actually it. This is the one where we will have the best conjunction possible. As far as I've researched, there's nothing else that comes quite as good as this. I may be wrong, but I think this is it. This is for our lifetime anyway. This is the best we'll get.
Thank you. All right, I guess if there isn't any other good question, I mean, they were all good. We can move on to the rest of the event. We have our panelists lined up to give a presentation. Chantal, can you see anything else?
Yes, we have a few more. Very last two, let's say.
Let's go for one.
Okay. The telescope in Spain, is it correct that the horizon is technically the top of the wall? If it is the top of the wall, are you able to raise the telescope above the wall?
Colin, this is for you. It's can you raise a 2-ton skill?
It weighs over 2 tons, so we can't raise the telescope, no. But we are higher. The situation of the observatory is actually higher than the horizon, so we can get pretty low. As Marco said earlier, this is 17 degrees, and getting lower. It's probably more like 15 now, so we're pretty low on the horizon.
Okay, thank you.
Thank you, that was fun. If you have any other question, yes, join our group on Facebook and we can discuss everything there.
All right, so before we move on to the presentations for Nick, Peter, and Adam as well, I think is with us. Adam, can you hear us?
Yeah, can you hear me?
Yeah, fantastic, excellent. So you're here as well. Thank you for joining. I wanted to show you this. So some of the questions were around, will I get a video, and you know, what about high resolution planetary imaging? Now, planetary imaging is something different in terms of the observing modality. As I said, you use CMOS cameras. You need very small, narrow field of views with very small pixel sizes. And what's actually possible, it's what you see here. So you see Saturn, Jupiter at a fantastic resolution. I mean, when I saw them from the first time, I couldn't believe my eyes. I mean, it's resolution that you would think from a spacecraft nearby the planets. And these images have actually been obtained using the 1-meter telescope in Chile. And from January 2021, we'll be offering planetary imaging from Chi-3, from the 1-meter telescope. It's a new observing modality. You need to be there during the session. So you book a session and you'll need to be there while you take the images. It's a video actually, so that was a good question. And you are going to be with one of our own staff that will help you and guide you through the observation together with the post-processing. The post-processing is completely different from the post-processing that we'll talk about in a moment. So, you know, this is our little gift for 2020. And I'll pass the floor to Nick, who will give his first presentation. Thank you.
Thanks, Marco. I'll share my screen with you. Okay, can you see that okay?
Yes, we can.
Is it okay? Right, okay. Well, I hope you're all enjoying the event as much as we are. I'm going to take this opportunity just before I go into this short presentation to discuss using observing the deep sky with Telescope Live, one of our questions earlier on was, what is the meaning of life? And I can answer that quite unequivocally. It's to do astrophotography. That's all you need to know. So for this short presentation, I'd like to talk about using the telescopes and the kind of results you can get. Now, I've been using the Telescope Live system for about a year now, after meeting Alex and Chantal at the European Astrofest earlier this year. And they've given me a great opportunity to try out all the telescopes. And I have to say, I'm so impressed with the results. It's taken my imaging to the next level. I've been an astrophotographer for over 30 years, and it's really just, dare I say, a quantum leap into the next level of imaging with the telescope. So we can start off with the most basic telescopes located in Chile, and we'll look at some of the pictures we can take using equipment like this. It's just a 200mm lens with a high quality camera, and this is actually a narrowband image of the Magellanic Cloud. Now, personally, I would never use narrowband imaging to image a galaxy, but of course the Magellanic Cloud, with its large Magellanic Cloud, with its proximity to Earth, to us, it's absolutely rich in so many of these deep sky objects, like the Tarantula Nebula you can see near the center of the screen. So just a humble 200mm lens gives you great images like that. Now, stepping up slightly to this Takahashi FSQ 106, they're located in Australia and in Oria in Spain, ICU Astronomy. And these are really nice telescopes, very high quality telescopes that give you great wide field results, such as this, which is the Eta Carina Nebula. Now, this is taken using narrowband filters, and all of the deep sky imaging telescopes are fitted with both narrowband and broadband filters. And it's up to us as users to decide which type of filter best suits the object that we're looking at. Well, this is such a marvelous object that both types of filters work really well. But for me, narrowband filters, especially when used with the colors that you see on the screen, which are known as the Hubble palette, really give you that step up to almost a Hubble-like quality. Remember, this is just a fairly small refracting telescope. And of course, for an observer like myself located in the Northern Hemisphere, objects like this were always below the horizon. We only saw these things in astronomy books. So to be able to log on and book an observation of targets like this, it's incredibly exciting. Also, you can take very, very short exposures using these telescopes because the sky conditions are so good, the instrumentation is so good, you don't need to take multi-hour exposures like we would if we were using our back garden equipment. An example of that is what you see on the screen at the moment, the North America Nebula, just a combination of 3 10-minute exposures. I believe this was a one-click observation, just using narrowband filters. Once again, the blues and golds of the Hubble palette. And also, if you're using broadband filters, these are luminance, which is effectively a clear filter, and red, green, and blue. Again, the Magellanic Cloud is a fantastic target. Once again, the incredible beauty of the Tarantula Nebula here, plus all the nebulosity you see. It's an absolutely wonderful target for the smaller telescopes. Now, also located in Chile are 2 of these telescopes, and these are absolutely incredible. These are 20-inch reflecting telescopes on direct drive mounting systems, and these have very fast F ratios, f3.8, which is very fast for a 20-inch telescope. And in everyday terms, that means you get a lot of bang for your buck. You can take really, really nice images in a very short period of time. And once again, I'll refer you to the Tarantula Nebula, an incredible target, and this is just a very short set of exposures. You can see now we're zooming in slightly, so we're gaining a little bit in resolution. And then you can step right up to this professional class 1-meter telescope on a computerized alt-azimuth mount. And this is serious equipment now, and very, very high quality optics. So once again, we can look at our old friend, the Tarantula Nebula, and you can see that with the 1-meter telescope with its enormous focal length, we're zooming right in on the target. And again, it's a target that responds incredibly well with narrowband and LRGB filters. This is actually a narrowband view using, once again, the Hubble palette. Another one of my favorite images, I took this earlier this year using the 1 meter telescope. And this is the fantastic galaxy NGC 1365. Again, always below the horizon from up here in England and Britain, but perfectly placed for the telescopes in Chile. And again, this is, although it's I think a lovely image, made up of a relatively short exposure set. And so it does show what can be done with those shorter exposure sets. And one of the most popular telescopes at Chile is, of course, the Chile 1, the 24-inch plane wave, very high quality instrumentation. I've used it quite a lot over the last year to zoom in on these southern targets, such as M83, a fantastic barred spiral galaxy, perhaps something like our own galaxy. Our Milky Way is actually a barred spiral galaxy. Maybe if we could fly out and look back at it, this is the sort of the view that we get. And with the slightly longer exposures, we can start to pick up the lovely faint background galaxies. Targets like this, again, globular clusters, you can unfairly say you've seen one, you've seen them all, but this is actually one of the very best in the sky, if not the best. This is Omega Centauri. Again, we can't see this from the UK. Very well placed from Chile. And this is another short exposure set just to capture the multitude of stars in there. And in actual fact, I believe the latest research suggests this isn't a globular cluster at all. It's actually a kind of stripped out core of a galaxy that maybe strayed too close to our Milky Way galaxy and was disrupted. And what we're seeing is just kind of the leftovers. But to all of us, I think it's pretty fair to say it's a really nice globular cluster. And Centaurus A, one of the most enigmatic targets in the sky. It's a collision of 2, possibly 3 galaxies. And we're just seeing it, a snapshot in time where the major collision is between the elliptical galaxy, which you can see the creamy sort of galaxy in the background. The sort of maelstrom in what looks like the foreground is the spiral galaxy that's been torn apart. And this, as I say, this is just a snapshot. You know, we don't know what will happen in the future. Maybe the shreds of that galaxy, you know, maybe the 2 galaxies will part, maybe there'll be another interaction. But we see galaxy interactions in the sky. But this, for me, is one of the most amazing because there's nothing else like it, I don't think, in the sky. And then this object, NGC 3324. This is part of the Eta Carina Nebula that we saw earlier on when we looked at the big wide field view of it, the Hubble palette image. This is a close-up of part of that nebula, that nebulosity. And I think it's a really evocative target because when it's displayed in these Hubble palette colors, the blues and golds, you gain a 3-dimensionality in these images, which I don't think you get in a lot of LRGB images. Nice pinpoint stars, and the Hubble palette itself is very good at sort of delineating features within these objects. So if you plan to use the Chile 1 telescope, remember this one, NGC 3324. It's an absolutely gorgeous and unique target. And then the Lagoon Nebula taken with the same telescope. I've often said, having taken and processed this image, that I don't think I'd have even recognized this as the Lagoon Nebula if I'd seen it looking like this. It's because it's an ultra high definition view of the central area. And once again, with the use of narrowband filters, we can capture that incredible structure that's hiding away in that central area. So again, another narrowband image. And then of course we have the favorites. This is M17, a nice nebula. It responds well to both LRGB imaging and narrowband. This is the LRGB view. Again, we can just about image this from the UK, but it's very, very low down in the sky. So to have access to this object using the telescopes in Spain and Chile and Australia, it's really marvelous. Now, I'm not going to say too much about image processing. This is just a talk designed to give you an idea of the excitement that you can get from using these telescopes. And I certainly do as well. But we're accessing new software. New software is being released all the time. And a lot of amateur astronomers, apart from using the famous software like PixInsight, MaximDL and Photoshop and all the others, there's a suite of software from a company called Topaz Labs. And this is one called Sharpening AI. And I hope it's very easy software to use, but I hope you can see the difference between the left image, which was great data to start off with, but the right-hand side, after a simple pass of the Sharpening AI software, it allows us to glean a little bit more resolution. And again, it looks to me almost to go beyond a sharpening process, almost to the effect of deconvolution. And with the high quality sampling rate of the telescope, so it's Chile 1 again, it gives us these great, we can process the data even further to eke out these results. And this is the end result of that previous image after I've applied the Hubble palette. And if I just zoom in on this, you can see that what I call a deconvolution process is basically a sharpening process, but you can see it ekes out that incredible detail, not only in the pillars of creation, which is incredibly famous, but also these Bok globules that sort of are located around the main Eagle Nebula. It really does give you that extra little bit of resolution, it seems. This is another example of software from the same company called Gigapixel. This is resampling software. So if you'd like to enlarge your images to create a nice print or a poster, software designed to do that, but it does actually work on astronomical images as well. And I'd resampled this image to just get it to a bigger file size. And I was amazed at how much more resolution it was able to sort of extract from this interesting galaxy. This is M82, and it's a very deep exposure set using hydrogen alpha and LRGB filters. But I hope you can see on the right-hand side how it's able to give us an extra sort of peep into the high resolution view of the galaxy. And also you can see it's tightening up the diffraction spikes from the telescope as well. And then again, a very enigmatic target, one of my favorites, which I've never really thought about before until using the telescopes. This is NGC, I can't remember its number actually, but it's its famous name is the Statue of Liberty Nebula. But I think for me, what sets it apart from the others is these incredible loops of nebulosity and all the sort of three-dimensional structure that's going on in here. It's a hugely enigmatic target, but a wonderful target for the Telescope Live telescopes. And this one, another recent image of the Helix Nebula in Aquarius, a very tough target from the UK, but thankfully we've imaged this recently from Spain quite successfully. And also this view with the Chile 1 telescope from Chile. And you can see lots of interesting features going on here, lots of subtle little background galaxies throughout the image. And the thing that I really like about this is the so-called cometary globules, these sort of radial effects that kind of stream away from the central white dwarf star. So a wonderful target, perfectly suited. And this is just an LRGB image, but a slightly deeper image. And then, of course, galaxy clusters. I put this one in just to show that we can also use the telescopes to create mosaics. This is just a 2-pane mosaic taken with Chile 1. And you have to work a little bit harder with these. You have to be able to point the telescopes quite readily. You need to have quite good accuracy on these. But, you can use software like Aladdin. And there's a great introduction to that by Adam on the Telescope website, so Telescope Live website. So if you haven't used that before, I find it's an incredibly useful piece of software. I'm working on a 4-pane mosaic at the moment, but I'm just waiting for the last bit of data to come through. And then just to finish off, I have to end with a sparkler, a nice object in the sky at the moment, a Christmas nebula, if you like. The Orion Nebula, it needs no introduction at all. But this, once again, is just a set of 3-minute RGB exposures. And you can see that with the quality of the instrumentation, the quality of the skies, the complete lack of light pollution, and it's very easy to get nice images like this using those very, very short exposures. So I hope that's given you an idea of what you can do with the telescopes. I hope you can pick up on my excitement at using them as a seasoned astrophotographer. And I recommend everybody give it a try and do try out your own hand at using these telescopes. So I'll hand you back now to Marco.
Thank you very much, Nick, for this beautiful presentation. And let me just say, maybe through Zoom and through YouTube, you're not seeing the real quality of these images. So these are high resolution images. You can simply go to our galleries, telescope.live/gallery, and you'll be able to see the very same images that Nick has shown at higher resolution. So it's really worth it. All right, so before we switch to Adam, if he's ready to with his presentation. Hi there. I just wanted to show you that magically somehow we're still imaging the event. So maybe we're looking through the wall. Let me share the screen, but it's still there. So Colin, you tell me how this is possible. We should be well below what's possible, but it's still there. I mean, it's very faint. This is one of the other reasons why we don't do any sort of high resolution imaging here. We're really looking through a wall here and they're almost disappearing. Yeah, see the quality of Saturn, it's really, really poor. I had a question here and I'll answer it just now about, are we tracking? No, we're not tracking at the moment. We're taking very, very short exposure, that's 0.2 seconds. It's really not worth tracking. So we usually, sorry, when I mean tracking, I mean guiding. We do track. So the mount will track the sky, but if you want to have pinpoint accuracy on the tracking, you do need to guide. But that's only important when you do very, very long exposures. If you don't, like now, you basically see the planets moving. So if you remember, these two planets were a little bit more on the right here, and they did move because of poor tracking in the end. So if you want to keep your stars in the very same position, you need to guide, and that's what we do when we take long exposure images as the ones that Nick showed. All right, so let me mute myself and I'll stop screen share and I'll leave it to Adam. Thank you.
Okay, I'm just going to say that it is morning still here in Arizona in the US. I don't have a presentation for this morning. I just got up and thought, oh, I'll log on and see what you guys are up to in Spain. So I was trying to observe the event last night. I had access here locally to a telescope that would give me access to see the conjunction. And it was wonderful just to say, I know this is all imaging, but before I put the camera on, it was nice just to look through the eyepiece and see Jupiter and Saturn together in an eyepiece. It was something really remarkable to remember. But if if there are questions, I just wanted to be available this morning, or my morning anyway, about either the experience of imaging them or looking at them through a telescope, just like the ones that you guys use down there in Chile and in Spain here. So. That's it. That's all I have for you this morning. I might be able to come back later for the other event. Maybe be more prepared with something. I don't know. I'm working with the images that I took just some odd hours ago to see if I can put something together.
Thank you, Nick. Sorry, I had to unmute myself. Thank you, Adam.
Yeah, sure.
Thank you very much. Right, so let me just say again, we're going to have a very similar event to this one in a few hours, actually, from Chile. So we're going to connect, as we did now, we're going to connect from Chile, and we're going to observe the same event at 1 a.m. Central European time. I mean, you can join that too, of course, but, the event will be indeed very similar. So let me pass the floor to Peter. So Peter, you can tell me if you have a presentation. I'll stop the screen share if you do. If not, I will keep the images from the scope running.
Yeah, I have a short presentation for you.
Okay, so let me stop screen share.
Is that okay? Can you see this?
Yes, looks good.
Yeah.
Thank you.
Okay. I'm going to start off with one of the images taken with Telescope Live, and I'm going to do a couple of minutes to answer a few questions that I keep getting asked as to why we astrophotographers do certain things. This is the dragons of Ara. which is an absolutely wonderful object in the Southern Hemisphere. And like Nick, I had never imaged anything in the Southern Hemisphere before Telescope Live. And I start by just quickly covering the couple of things that we do to image. And stacking is the first one. So you'll hear Nick say that they were taking 10 images, or I took 4 images. And the reason why we do is because it improves signal to noise ratio. So that's why we're using multiple exposures. This is the Rosette Nebula, image from here at home. And this was the final result of that one. I just wanted to say about image calibration, which comes up all the time and I get asked about all the time. We take biased darks and flats. The advantage of Telescope Live images is that they're already calibrated for you. I'm not going to go into in much detail, except to say that if you want to, you can get the raw images and the darks, flats, and bias frames from Telescope Live and process from that, if you want to. You've heard Nick talk about the filters, so I'm going to briefly explain the filters a little bit that we use. So we've got our red, green, and blue. The visible spectrum is only a small part of the electromagnetic spectrum, as I'm sure you all know. Red, green, and blue filters with a gap, intentional gap in the middle, which is the wavelength of most streetlights, mercury and sodium vapor. And then we use narrowband filters, which again you've heard mentioned. So hydrogen alpha filters. I'll just very briefly put this in. If an atom of hydrogen is excited, and it's usually ultraviolet, the electrons tend to jump through energy levels. I think you can see me pointing to this. The Balmer series is the ones in the visible spectrum. The others are outside the visible spectrum. So we're concerned with this one, the Balmer series. When we excite electrons and they jump this jump, they emit a photon of light when the electron jumps back down again. And the photon of light emitted is at the wavelength that we use for the hydrogen alpha. So that's 656 nanometers. And if you can see this whole screen. Oxygen is energized, it's ionized, so light is given off. And the same is true of sulfur. They're at different wavelengths. If you can see this graph, you'll see where they are. The oxygen is somewhere between blue and green, and the hydrogen alpha and the sulfur 2 are at both in the red part of the spectrum. So we use something called color mapping, and you've heard the Hubble palette mentioned quite a number of times. And the Hubble palette assigns the hydrogen to red, or sorry, sulfur to red, hydrogen to green, and oxygen to blue. And you get these familiar images that Nick showed you. This one was actually one taken from home. The Pelican Nebula. You'll see on this exactly what we're doing in that the sulfur is in red, hydrogen is shifted to green, and oxygen shifted to the blue. There are lots of other ways of doing that, or assigning the colors. This is a picture taken from here of the Veil Nebula, and this is a bicolor with oxygen and hydrogen only. I'll just show you how that one is mapped. So hydrogen goes into the red and the oxygen goes into the green and blue. There's an image taken recently where there's another type of mapping where the hydrogen is in the red and the sulfur in green and blue to try and show some detail in the Seagull Nebula. And this is an image taken from here of the Heart Nebula. And this one is the Hubble palette, but with red, green, and blue stars added. Okay, so I hope that explains a little bit to some that might want to know. I think as Nick's already said, access to northern and southern hemisphere objects. I found this on the internet, and it's a little diagram that shows that if you're in the northern hemisphere, there are some constellations always visible. If you're in the southern hemisphere, the same is true. But of course, if you're in the northern hemisphere, you can't see these ones. They're never visible to us, and vice versa. To plan targets, I use Stellarium, and this is a target from here. So this is set for my Earth, for my home location. And this image was taken from Spain. And I think Nick already showed the North America and the Pelican Nebula. This is in the Hubble palette. And this is what excited me so much when Telescope Live came on stream. And I've been using it for about a year as well now. This is actually set up for Chile. It's Stellarium. The object at the top is the Carina Nebula. And the Carina Nebula. And this is imaged from Chile. And the object at the bottom is the Running Chicken Nebula, also imaged from Chile. A fabulous definition in this one. One of my other bugbears, as Marco said at the beginning, was light pollution. I live in the UK, somewhere in the Midlands, and you can see that the map of light pollution is atrocious. Where I am, it's a red zone. This is in fact my observatory at home. And the street light, as you can see, disrupts just about everything. It's my home observatory. So this is a shed with which pushes back. It's on casters, it pushes back. And this is my home scope. And you can take reasonable images from here, but from here, you can take wonderful images. This is the observatory in Chile at El Sos is at an elevation of 1,525 meters above sea level. And the seeing there is incredible, not at all like here. These images, the Prawn Nebula and Thor's helmet were taken from Chile. And I just say, in the weather in the UK is the other thing that causes us a lot of problems. Again, Marco mentioned weather. You can see here that in the winter, we've got about 10% of nights are clear. In the summer, we get a little bit better than that. We get about 20–25% clear nights. However, in the UK and at similar latitudes, in the summer, the sun isn't really very far below the horizon. So in the summer here, it's difficult. Certainly midsummer is very difficult because the sun starts affecting everything. In the UK anyway, there's quite a difference between the very south of the UK. It's about a month when it's difficult to image. But if you went to the north of Scotland in the UK, it's about 3 or 4 months. But from here, this is, of course, in our summer, it is midwinter in the southern hemisphere. And they have around about 300 clear nights at El Sos. I go back to the image taken from there of the dragons of Ara. And again, some of this equipment has already been shown. This is the 610 millimeter plane wave. Wonderful telescope. And I took, as Nick has, a picture of the Eagle Nebula with that scope. And the 1 meter telescope there, I used to take the Trifid Nebula. And my favorite scope, which I think Nick agrees with, are these two. There are 2 of these scopes in Chile, and I absolutely adore these. They're very fast scopes, plenty of light gathering. And I took this picture. I think Nick showed a RGB image of the swan. This is a narrowband one. And again, a narrowband of the Statue of Liberty Nebula. And as Nick said, there's a scope in Australia, the Heaven's Mirror, and it's a Takahashi. And I've only used it for 1 or 2 images, but this is a picture of a Carina Nebula from there in RGB. And the telescope that we've been using tonight is in Spain. And I took the image of the Pelican Nebula and the North American Nebula from there using that scope. And this is the scope that I haven't actually used yet, but is the one we've been using this evening. You can see the wall that we've now gone below. I was astounded at the quality of the data that was coming in. And I'll go back to this image of the Carina Nebula, and I'll zoom in to this one a little. This is 3 10-minute exposures through each of the narrowband filters, hydrogen, oxygen, and sulfur. I hope you can see it in the definition that I can. It's astounding. The data was so good that I thought, well, I wonder what a single exposure, 10-minute single exposure would look like. And that's what it looks like. So that's just 1 10-minute hydrogen, oxygen, and sulfur exposures. I had a quick look at the new website on Telescope Live, and the three of Adam, Nick, and myself are on there. There are quite a few tutorials, and the one that I've just showed you of the North American and Pelican Nebula, the processing tutorials there. And I'm intrigued to see that there's you can now download the data sets for these as well to try out processing techniques. I think Nick actually showed this same image when he's during his talk. There's a Gabriela Mistral Nebula, NGC 3324. The Lagoon Nebula, a slightly wider view than the one Nick showed. There we go. And this is, that's just my favorite object in the sky. I just think it's fabulous. Wonderful. And the quality of the data is astounding. Okay, that's my lot. Thanks very much.
Thank you very much, Peter, for sharing these beautiful images and some background on astrophotography. Before switching back to Adam, as far as I understand, Adam wants to say something about his experience yesterday. I just want to share my screen to show you what's happening. So, Colin, we are hitting the wall, I guess. So we're not looking through the wall anymore. You can just see Saturn there. It's a blob, and another blob is here. This is Jupiter. So it is disappearing behind the wall, but we'll grab the event later today at 1 a.m. local time. Well, my time, in a few hours time from Chile. So if you want to see it again, you can connect again, and you'll see the event as observed from our telescope in Chile. I'd just like to go through some quick questions before we go back to Adam. Chantal, I'll get back to you. There was one which I actually wanted to revert back to Nick, Peter, and Adam, because you are astrophotographers, you've been using your own gears all the time, and some people are asking, well, if you haven't taken the picture with your own scope, you can't claim the images are yours. And you know, one of the aspects of remote imaging, it's true, you're not there next to your gear taking these images. So what's your feeling, and what's your suggestions for everybody here today, and what's the relationship between taking the images by yourself and doing astrophotography through a remote imaging service? Who wants to go first?
I can take part of that, I guess. So there are basically two parts of the equation in astrophotography. There is acquisition, which is the collecting of the data, and then there is the processing of the information, right? So if you're fishing, part of the game is to catch the fish using the right technique and the right equipment. I'm not a fisher, I'm not an angler. I have no idea how to catch a fish. But I presume that you go out on the boat, you've got the correct gear, and you know where the fish are, you know how to find them, and all of that kind of stuff, and you catch a fish. Now later you're going to cook the fish. And when you cook the fish, that's a whole different part of the game, right? Because you want to sit at the kitchen table and have a nice meal with your fish that you caught. This might be a terrible analogy, but I'm going to claim that the chef that cooks the fish they're going to say that the acquisition of the fish is, I mean, it's nice that you get a nice fish, and that is critically important. But then what happens afterwards, as far as the cooking and eating of the fish, that's a very different part of the process. And I don't think the chef is going to say that, oh, because they didn't go out and fish, they didn't get the fish themselves, that would somehow lessen the experience of what they cooked and ate. So I think they are two parts of the equation of astrophotography, and both are certainly significant. It takes a lot of sweat equity to understand a piece of equipment and make it perform in an optimal way. But that's part of what you pay for, Telescope Live, is you're paying for the people to make sure that all of that works very, very well, so that you've got a good fish to cook and enjoy. And that has been a joy for me in the small opportunities I've been given to use the Telescope Live data, is then to put together that data. And as far as the art is concerned, the art of acquisition is constrained by equipment and location and things like that. There's only so much you can do. But I think there is more expression to the processing of the information when you actually have the data in hand and you work with the numbers, because it is open-ended as to what you can choose to do as far as the decisions that are made for the processing of the data. So you can hand data to, two people, myself or anyone else, and you'll come up with a different result. And that's a personal expression of, what you've captured. Just like the chef that might cook, some other chef would cook a fish in a different way and it would taste completely different. That's all. Was that a bad analogy? Was that a terrible analogy? I don't know why I picked a fish, but I did.
Nick, Peter, I don't know if you want to add on this. Yeah.
Yeah, okay, I'd agree with that. I think it's like when you're using Telescope Live maybe to use an advanced observing request, you're making that conscious decision to use a particular telescope at a particular time of the year with the moon, summer in the sky maybe. You're making that decision about whether the end result is going to be worth using that telescope time on. So I think, there is a conscious decision there, and it's only a small one, but there's something there where you're actually making a decision about the end result. And then, of course, you're in the lap of the gods in terms of how the observing run goes. But once the data is secured, then it does become an incredibly personal result. As Adam said, and I couldn't agree more, and having done a lot of presentations to different astronomical societies and camera clubs and things like that, I can say quite honestly that we could take that original sort of latent data and give it to 20 or 30 different people and then say, go away and come back next week and let's have a look at how you processed the image. And every single person will have done it differently. Some will do it good, some will do it bad. Image processing is like learning a language. You have to do it every day effectively before you can get good with it. There's no royal road, shall we say, to a good processed image. It's something you have to work with and learn from your mistakes. So I find using the Telescope Live telescopes in Spain and Chile and Australia a hugely rewarding experience, because we're able to image these exotic targets but receive very, very high quality data that then you can put your own personal stamp onto that will be different from everybody else's. So I'm perfectly comfortable with that. And I would say, just before I stop, I have got a back garden observatory. I've also got a remote telescope shared at Collins in ICU Astronomy. So for me, Telescope Live is just a great bonus to be able to get the kind of images that we can. So I think it's a great experience, and I'm very comfortable with it.
Yeah, and I would agree with both of Nick and Adam. It's an incredibly rewarding experience to get the quality of data that we're getting and to see objects that we can't normally see. Not a lot more to add, and I've heard that comment made quite a number of times.
Thank you, Peter, and thank you, Nick. Chantal, I don't know if there's any other question we want to answer.
Yes, I muted myself. And let's go with other few questions. There's one I'd like to address to you again, which is, what is the most prevalent post-processing application used? Which one do you use? What do you think is the best one? Yes, please, you're muted.
This is for the astrophotographers, the real astrophotographers. Tell us what you use.
I personally use PixInsight and Photoshop, a combination of both, plus a number of other tools. The tools that Nick mentioned earlier of Topaz Labs are exceptionally good. I use astronomy tools. There's a couple of Gradient Exterminator is another that I use. So it's just a question of seeing what new comes to the market, trying it and seeing if it's worthwhile addition to your processing workflow.
Yeah, I've been fortunate that when I began astrophotography, it was a time that it had just really begun in the kind of the early 90s when software was being developed for amateur astronomers with the nascent cameras that are available then. So I've been lucky to go through at least, 6 or 7 different popular processing type programs, in addition to things like, Photoshop. So currently I'm using PixInsight for a majority of the processing that I do, though I would argue that one of probably the most powerful things to really get a hold of is more, it deals more with there is a larger kind of set of knowledge that just deals with image processing in general, with the type of data that you're working with and so on. And that is a constant throughout any piece of software. It's that understanding that really allows you to, when a new software does come on the market, it allows you to understand what its features are and how it might be nice to use for you or not, and so on. So I do think that there's a greater kind of learning that comes from image processing that is general to all software, but some software has the nice tools in it. Currently, I'm using PixInsight.
Thank you, Adam.
Thank you. Next
Let
question.
me just say, I've answered some of the
Yes,
questions
please.
on the chat here, but could we get these presentations? Yes, we'll distribute these presentations to our Telescope Live users. And another one was about, will we get the recording for this event? Yes, you will. You'll have it in YouTube as well as on our platform. But if you miss this event, you can join later today to the second event, which we're going to host from Chile. And right, so I guess we're about to end this this event. Before, I mean, you can see the planets have disappeared. I'd like to pass the word to Adam, who's going to show you how he got these images last night. I guess it was last night for you, and the sort of images that he got. It's a different perspective. Here we're using a CCD camera on a large scope, so we'll show you what he did. Let me just say before we end, and before we pass the word to Adam, join our Telescope Live community on Facebook. You can search Telescope Live community and you can join today. And if you haven't done so, you can start your free trial at telescope.live and try. And you can also you'll be able to become an astrophotographer in no time. So thank you very much, and Adam, I'll pass the floor to you. You need to unmute.
Yeah, is this something where I can actually share my screen? Yes? Okay, I will try to share my screen. Just didn't want to randomly do it. So one of the things I wanted to do is to just point out some, because they were showing pictures that they took at Telescope Live. I wanted to show my own pictures. I got jealous, basically. So these are a few of the pictures that that I've taken using the opportunities that I've had. This is GUM 15, which is a fantastic nebula near the kind of the Vela region of the sky. And I had always wanted to take a picture of this thing, and it's just a beautiful nebula being strongly illuminated by a very bright star in the middle. The thing about the processing in this case, the decisions that I made were to make sure that I could highlight. It's a strongly dominant red object, but I wanted to highlight some of the blues that are in this object. So I paid particular attention in processing to be able to maintain the color contrast wherever I could to enable me to show off some of the blue nebulosities and so on. And this is another opportunity I had to use the 1 meter telescope, which I'll point out there's been some improvements made. Part of the challenge, if anyone had watched my tutorial about the trials and tribulations that I went through to try to put together the data, all really revolved around these stars. Because that's an ALTAS system, the field rotates as it goes across the sky, keeping the correct orientation of the object, but unfortunately the diffraction pattern being fixed with regards to the telescope, it rotates even though your object doesn't. And that makes for some funny looking stars. But if you remove the diffraction around stars or you minimize it, then this minimization, I think, actually improves the image quality. So it's my understanding that that minimization of the diffraction has been applied to the large telescope, and that would only improve the ability to take pretty pictures. What I would mention here is that an object like this, what excites me is to take a picture of something where there may not be very good pictures of them, and the universe is vast. I think this is another component of Telescope Live, is to really give access to the universe in a way that many other systems, you just don't have that kind of access. So to take a picture where you can be one of the first people to really see, do you see these little things right there? When I took this picture, or some of these things, I may have been one of the few people who have ever really gotten to see these little features of this galaxy, because there really are very few high resolution deep images of this thing in broadband color. So that excited me. And then finally, another kind of thing of the sort, here's just some nice spiral galaxy, NGC 2835. There just really weren't that very many nice pictures of it. As far as that's my experience with some of the telescope stuff. As far as my experience with last night, I haven't yet processed the information. So what I can show you is kind of an overview in the sense that, let's see, is it here? Yeah, of course, when you do this live, it's hard to get right. Let me see if I put it in here. I did. So this is what it looks like for the conjunction in the sky. If you've got some good vision, you'll be able to see the two blips of Jupiter. In fact, if you look really closely here, you can see there are two moons. With this is like a 4-second exposure or so. Yeah, I can barely see the moons there, and Saturn looks a little oblong. But this is over the city of Tucson as it's setting over there in the southwest. And this is what it looks like if you take a picture. This is the raw data using not a camera, not a CCD camera, but instead an actual DSLR. So this is actually a relatively new camera for me. This is the Canon RA. I was really excited to use it. Now, of course, I don't have the lens on when I attach it to the telescope. So I attach this to well, this is the telescope that I can get access to sometimes. It's the 32-inch telescope just right in my backyard on top of Mount Lemmon. Backyard meaning I have to drive to the top of the mountain. But it's used for public outreach. And I had a chance to use it for a couple of minutes to take some data of the conjunction. So in this picture, you probably can't see, but it's black and white. And you can see here is Saturn and Jupiter. But if I debayer the image, you'll actually see there's a color. At least there should be color. It's going to take it a moment because these are big frames. That's one of the nice things about doing color in one on a bright object. This is rarely easy to do with a, something that is very faint. You wouldn't want to use a DSLR in general. It's not optimal to get the most light that you can in a particular period of time. So if I very quickly, and I can't promise you this is going to work, but I will try to do the following. This is going to try to color balance the image so it looks like at least not a green thing, but something that is more like you would expect. So in any single frame, they're going to look somewhat fuzzy, right? But then hopefully, as you, can you see the cloud tops of Jupiter there? So and you can see the red spot. So this particular frame is a little bit fuzzy, and somewhere in the upper left here is Saturn. One of the difficulties with doing this is to be able to expose them both for the right amount of time, and you can't because Saturn's so much fainter than Jupiter. It reflects more light, and it's closer. So part of the challenge here will be to do that, to see all features of this pair, to see the moons of Jupiter, to see Jupiter itself, to get a nice view of Saturn, all in the same field of view. But that's generally the data that I'm working with here. And I hope to co-add many, many of these frames to produce, I hope will be a nice image. But that's what you can do, even if you're not doing video. You can do single frames and take a whole bunch of them and add them together to hopefully make for a nice image. We don't need to show it now, but if you want to link, if someone wants to link to that video that I made on YouTube, it'll give you a sense of what I was going for. Of course, I still haven't done it, although now I have some data in hand. It was the pre-show video, and hopefully the post-show will be a post-processed image. So let's see if I can stop sharing.
Thank you very much, Adam.
Yes. I'm going to try to stop sharing. Oh, there we are.
Sorry, a video started in my background. All right, well, I guess we reached the end of the event. The planets have now set below the horizon, so we can't see them any longer, but we have another event in 5.5 hours time. That's it. Yes, 5.5 hours. We're going to reobserve this from Chile. So if you've missed the conjunction, if you've missed the pictures, the live stream from our telescope in Spain, you can join us later, and we'll have another event in which we'll observe the Great Conjunction from Chile. So thank you very much again. Thank you very much to all our panelists, Chantal, Nick, Peter, Colin, Adam. Who else do we have? Alexander, of course. Hi there. And thank you very much to all our Telescope Live users who've joined today us on Zoom. And thanks also to all our YouTube viewers. Go to telescope.live and try it. Thank you.
Thank you very much, everyone. It was great, fun, and interesting.